So this is the review from Tuesday morning. Now we go to the new session 2.7. We talk about parameters of synchronous generator, right? How to measure the parameters. First of all, you need to understand what are parameters, right? Parameters. Before you do measurement, right? For example, if you get a fever, you need to measure body temperature, right? You need to measure blood pressure. Yes? Of course. So if you would like to measure, to operate the synchronous generators, you need to know how many parameters we need to consider. Yes? Of course. Okay? So now we have stator, right? And we have rotor. Okay. So for stator we have AI, right? We have V phase. Yes. We have IA. We have XS. We have I. Okay. So if we consider the line voltage, we have VL or V terminal. That's mean terminal voltage of stator voltage. We have IL. This is phase current, phase current, phase voltage. This is line current, line voltage. What else? VR, I mean three-phase reactive active power. We have Q, three-phase. We have S, three-phase. What else? Load. Okay. We need to consider what kind of loss we have. We have three, right? We have resistor load. We have inductive load. Yeah, we have capacitor load. Why? Why we need to consider the load? Because if we know exactly the load, we can draw phasors diagram, right? Yes. For example, this one is unity power factors. This one is lagging power factors. This one is leading power factors. Understand? Yeah. And of course, for both stator and rotors, we have many power losses. We have delta C, delta BC US, or sometimes we say delta BC LNSC, SCL. We have delta BF. That means the power loss coming from field winding or rotor winding. So here we have delta B ICL, we have delta B FE, we have delta B friction and windage, we have delta B strike. Okay? Yes. Okay. For rotor, we have what? We have VDC. Because we supply DC voltage into the rotor winding, right? We have IF, we have RF, okay? Yes. Yes. What else? We have rotor speed, right? So if we have rotor, this is rotor speed. So we can calculate omega m. This is angular frequency. This is 2 by Nm over 60. Okay, we also have FSM over 2 times the number of pole pairs, or you get FSM times, sorry, this is the number of poles, because by 2, this is little, so this is the number of pole pairs. Okay? Yes, and then we also have NC. What does this mean, NC? This is synchronous. Syn mean synchronous. And equal to what? 60 F S is over B. This is little, you know, this is little. Okay? Yeah. So now we understand. Of course, we have in due talk blah blah blah, but I think yeah, it's fine. Okay, for all parameters of theta and rotor weight. Okay. So go back. Yeah, the equivalent circuits of synchronous generator has 3 quantities. Okay, we have EA, XS, and I. Okay, I means armature resistance. Why we have 3 quantities here? Because we come back to the voltage equation, right? We have voltage equation, synchronous generators voltage equation. We have V phase, right? Is EA minus J RA, sorry, minus what? Minus IA, okay, RA plus JXS. Okay, of course this one for lacking power factors. Did you agree with me? Yes. Okay. So we need to measure. We need to measure EA, right? EA. No. Yeah. We need to measure EA. We need to measure XS. We need to measure RA. You know, very easy for you to measure resistance and reactance because it depends on the construction of synchronous generator. Okay, and then if we come back to Faraday law, we have E okay, equal to K phi, and then omega. Right? Go back to Faraday law we discussed from lecture 1. What does this mean, K? K is mechanical construction factor. Omega here is omega m. Okay, phi m is the rotor magnetic field across the air gap and come to stator. And this is omega sins or synchronous angular frequencies. Okay? Yeah. This is constant. This is constant. No. When we fix the speed, omega m is constant. So we have the observation. So when we increase phi m, that means we increase EA. When we increase, Im, this is rotor, right? This is rotor's magnetic field. So when we increase phi m, that means we increase IF. Increase IF, right? What does this mean, IF? Field current, or we say this one is rotor current. Okay. Otherwise, if we reduce IF, reduce phi m, reduce EA. Okay? Yes. Any questions? Okay, continue. So, to measure the parameters, we need to implement the open circuit test. The open circuit test, we say OCC test. Okay, so now we have the first test, OCC. That means open circuit test, OCC. Okay. The question: what is open circuit test? What is the open circuit condition? That mean no loss. Right? Open means no loss. That means we disconnected the stator windings of synchronous generator from the load. Okay? We say open circuit. So no loss. That means IA is 0. IA 0, so we phase is EA. Okay? So now V phase becomes VOC. OC means open circuit. Okay, that's right? Yes. Yes. Okay? Yes. And we have before we go detail this diagram, you have 1, 2, 3, 4. You have 1 minute. Read this description. Okay, read it. You can get more understanding. I also explained to you before, right? Okay, are you finished? Any questions? Oh, good. Okay, so now continue. Look, now EA, right? And we know EA is calculated by K phi m omega c. Right? Yeah, right. Yeah. So remember that. So now we have VH curve. It's in B, it's in phi, it's H, it's E, magnetic force. What else? We have I. This is IF. This one is IF. Why? Why IF? Because we have no IA current. Yes. Yes. So we have the curve like this. Yeah. I also explained to you why we only consider the first quarter. Right? Yes. Okay? Yeah. So when we increase IF, that means we increase phi m, right? We increase phi m, that means we increase EA. Do you agree with me? Okay? But remember that we have the limitation of magnetic core. You know, if we continue to increase IF, after some time you get saturation zone. So here here. This one is saturation at saturation zone. Okay, and in this region. This region. Okay. So when we operate the synchronous generators, please take into account the saturation zones. Okay, we try to avoid the operation of synchronous generator in saturation zone. Okay. And this one like linear, right? Linear relationship. Here is linear regions. Okay, yeah. So this is linear relationship. So if we know IF, we can know phi or IF or EA. Okay, is it clear? Okay, so yeah, I also explained to you. Yeah, yeah. Blah, blah, blah. Okay, 1 minute. Continue to read this slide. I already explained to you. Okay, so now you read information in this slide, you can get more understanding. Okay. Yes, this one is saturation zone. Any questions? You know, if we look at here, sometimes they use EA, sometimes they use VT. EA means phase voltage, internal phase voltage, and VT means line voltage. Remember that. Okay, but very easy, you know, because we know EA is V5 in this case. So we can calculate VL very easy, right? VL or VT shows is 0.3 phase. Understand? Yes. Continue. Now we go to another test. We say short circuit test. You know why we use these smart university, but very steady designs on whiteboard. I'm thinking about where can I write. Maybe short circuit test. SCC. Okay. What is it? This one is phase equivalent circuit of synchronous generator. You know, Mr. Hill, who is a lab engineer, he designed the PPT slide for me. He is very good at English. He gets 8.5 IELTS. Yeah, he is very good to write the technical report. You know, very excellent. So when if some of you do the bachelor thesis with me, normally Mr. Hill is the second supervisor, and he will help you to correct technical writing. Okay. Every year, he and me I publish some paper. Okay, it's very good. Back. So for short circuit test, so for example here we have plus, minus, minus. Yes, right. This is phase A, phase B, phase C. Okay. So we have here is AA, AB, AC, okay, and this is J's axis, and J's axis. Of course, we assume this RA is 0. Okay, so if RA is different from 0, of course we have RA, right? Now RA. It depends, depends on the assumption. Okay? Yes. Or RA different from 0. And of course we have a lot, right? We have a lot. A. A, B, C, right? C. And then we have neutral point. Okay? Yeah. So we know this one is phase voltage between A and B. This A line voltage. Okay. So if we have short circuit. If we have short circuit, that means A touch B touch C. Touch C. Right? A, B, and C, you know, is shorted. Are shorted, sorry. So we have A, B, C. Okay? Yeah. Are shorted. Okay? And of course, this one we have IA, yeah, and we have rotor, right? Omega M, rotors. Okay. So if we have the short circuit condition, the rotors is also rotating. You know. So if rotors are rotating, you know, VL is very high. It's very high. How can we control the rotors? We have water turbine, gas turbine, steam turbine, right? Okay, so the power is always very high. Root of 3, V line, I line, cosine, inverse. You know, the power is very high. But if we have short circuit, the voltage here is 0. Right? Right? If we have short circuit, you know, the resistance is very small. So the voltage is approximately 0. This one is approximately 0. That means IL very, very high. Because output power is constant. Right? The speed of the rotor is constant. That means the output power is constant. This is constant and VL is very small. So IL is very high. Okay? So we need to isolate. We need to isolate the synchronous generator immediately. Otherwise, boom. Okay, your synchronous generators will be worn out. Okay, that is the reason we say short circuit. Short circuit. So when we do the test, before we do the short circuit test, you need to make sure you reduce the output power first. How can we reduce? We reduce Nm, right? We reduce Nm. So if you go to the lab and Mr. Hill guide you to do short circuit test, okay? Please remember in your mind to reduce the output power. Otherwise, you fail the lab session. Doesn't mean you fail this course. Okay, because very high current. And it's very dangerous. Why? Because of course we have some protective device to protect you, but you cannot believe the operation of protective device 100%. No. Okay. So if unfortunately the protective device is not working, you say goodbye to your parents. Also your girlfriends or boyfriends. Okay? And I also die with you because I am a lecturer. Maybe I will go to the jail because you die. You understand? Not kidding. This is true. Yes. So remember that when you make the short circuit test, please double check with lab engineers. Okay? To make sure everything is going very well before we make measurement. Okay? So come back. Now we modify this equation, right? Number one. So number one, continue. Maybe yes, here. Number one. We modify, revised. Okay, we have E, we have V, we face E, EA minus RA plus JXS times IA. Okay, and we know if we have short circuits, this one becomes 0, right? 0. So we can get EA is RA plus JXS times IA. Okay? Yes. And we know EA proportional to what? IA is directly proportional to K phi m omega. We discussed before. Where is this? Where is it? Here. Okay? Yeah. So if we would like to reduce IA, we need to reduce EA because this term is constant. Am I right? Yes? So if we would like to reduce EA, we need to reduce phi m or omega. Very difficult to reduce omega because the water turbine or gas turbine is very large. We need at least 30 minutes to reduce gradually the speed of water turbine or gas turbine or steam turbine. So we forgot this one because this is impossible. Okay? And of course we need to isolate immediately the fault. But if you wait 30 minutes to reduce the speed, oh my God, you are stupid. Okay? Maybe 1 second you are died. And you cannot wait for 30 minutes or 15 minutes. So we think about, we reduce phi m. Reduce phi m, that means we reduce what? We reduce IF, right? So if IF is 0, AI is 0, and IA will be 0, all the equations here are linear equations. Okay, so that is the reason we have this one linear equation. So here is IA, okay, and here is IF. Maybe it's capital or little, but that's okay. And this one is short circuit curve. In raise IF, in raise AI, in raise IA, reduce IF, reduce AI, reduce IF. Okay, you get this one. That's it. Do you understand? Khoa không? Khoa, do you understand? Good. Này bằng cái tặng có này mình để vậy. Không hả? Ăn mua giờ ghé không hả? You know, when you attend my class, you can carry this one. But when you take the final exam, to be careful, you know, maybe with the heel to let you go out. And maybe inside here we have some communication device. Okay. Yeah. Okay, so of course we can calculate the short circuit current. Okay, so short circuit current is IA is EA over RA plus JXS. Remember, so, this one is vector. Okay, yeah. So if we only consider the magnitude of the short circuit current, okay, take absolute values, and here this is complex number. So when we calculate magnitude, we take the square root of RA square plus XS square. Okay. Is it clear? Để sao gì cái thế hệ giờ mã này của gì? Tính chào hả? Okay, yeah. So we also draw the short circuit test phasor diagram. Okay, phasor diagram. Very easy. Okay. So now V phase is 0. V phase is 0. That means zero vector. Do you know zero vectors? Zero vector is different from zero point. Do you agree with me? Yes, of course. So we have IA. Of course, here we have armature resistance. We have armature reactance. So this one lagging, right? This is lagging. Okay. So this is lagging. So here is this is x-axis. So this one is IA. Okay, and we have the phase angle here. Theta. Do you know how to calculate theta? Yes, of course. How to calculate theta? We have tan theta is xs over I. Did you agree with me? Yeah, right? Yes? Okay. Or we can theta. So what is theta? So remember that this is a short circuit phase angle. So short circuit phase angle is tan to the power of -1 xs over I. Do you know I? Do you know xs? Okay, it depends on the specification of synchronous generator. You know xsi. Okay. Short circuit phase angle. Okay, so continue. Yeah, like this. So we need to draw IARA. Maybe here shorten a little bit. Okay, this one is IA. So here you can get IA, RA. Do you read? Because IA is in separation with IA, and then you can get okay. Then we can get here is a chase XS IA. Okay. Remember that I here is short circuit. And then we can get, so this is the phasor diagram of short circuit test for synchronous generators. Any questions? Okay. So according to the phasor diagrams of short circuit test, we also indicate the phasor diagram of magnetic field, right? We have BR is in the same direction with AI. We have B net, okay? We have B stator, okay? Yeah, B status is perpendicular to II. We discussed before, right? So if we know II, you can get B start. Okay, and we take the sum of BR and B start, we get B net. Okay, yeah, we studied before. Okay, so yes, this one for your review, right? We have BR in parallel EA. B start is perpendicular to IA. Of course, this one is phi m. Questions? Why I know here is phi m? You know, I also introduced to use EA is always log into phi m 90 degree. Do you remember we have Faraday law? We talk about is minus n d phi over dt. This is EA, right? This is phi m. So if here is always A, so here is always phi m. That means is log in phi m 90 degree. Remember that? Okay, good. Okay. That's all. Oh, continue. Yeah, I have some Vietnamese here because I am afraid that some Vietnamese students will not understand this one. Okay, but I think all of you are really smart and can understand. Okay, 3 minutes. 3 minutes. Try to understand this slide. If you don't understand, ask ChatGPT. We will explain to you. Okay. Okay? Continue. You understand? If you don't understand, I don't understand too. Quite surprising. Okay. So, explanation. Yeah. We have of course for short circuit test we have RA and XS. Okay. Yeah. So we can calculate ZS. ZS. What does this mean? ZS mean synchronous impedance, right? Impedance. So we can calculate ZS. I mean magnitude. We know ZS is RA plus JXS. Okay. So when we take the actuals, we have RA square plus XS square. Now, very easy here. Okay. So now we have the ratio. The ratio here. What is this? What is this? So we have the ratio. So if we come to this equation, right? We have EA over IA. Do you agree with me? Yes. Yes. Okay. But now I here a short circuit, and this one is rated. Right? That means we keep IF, we keep the speed. So EA now is rated parameters. Okay? So if EA is a rated parameters, IA is a short circuit. Okay? Yeah. So here EA is rated, mean rated internal phase voltage. Okay, this is very high. And IA short circuit mean short circuit stated current. Do you understand? Okay, but you know ZS is always constant. So if I reduce IA, that means I reduce EA also. So we have this ratio EA over IA. Okay. So here I reduce IF. Okay. When I reduce IF, okay, after some times I get IA rated. Right? IA rated. Okay. Of course, IF is very small. So if here is IA rated, okay. You know, IA rated is less than IA short circuit. So EA is also reduced. Okay. So here I say EA short circuit. Okay. So EA short circuit mean the short circuit internal phase voltage when IA is IA rated. Okay? Because if we do the experiment, we don't want to reduce IA. You know, IA short circuit is very high. And then the generators will be burned out. Oh my God, you are so stupid. Okay, so when we do the test, we try to increase a little bit IF. When we increase IF, okay, at the same time we observe IA. So if IA get IA rated, stop, rated AI. by using voltmeter, you can calculate this. Like transformer experiments, we have short circuit test for transformer, open circuit test for transformer. Okay? Any questions? Any questions? Questions? Next year's summer semester 2026, I will cover fundamental of power engineering, because I recognize that we have flying faculties, but I get some negative feedbacks. So next semester I will cover this course. Oh my God. Okay, I'm lazy to teach, I am very passionate in research. I'm lazy to teach, because I teach many years. Okay, I have 10 years teaching experience. Any questions? In Vietnam, okay, you can reach the reputation by research activities, not teaching. Teaching activity cannot let me have more money. No. Research. I collaborate with companies. Okay, but teaching absolutely no. Or you just get a little bit of money. Okay, sometimes we have training costs in the company, but okay. Any questions from this equation? Any questions? If you don't have any questions for me, I have a question for you. Please explain this one. Please explain this one. How can we get this one? Of course we know this one. This ratio. Okay. So if xs is much higher than Ra, so that means you can skip Ra. So now that is approximately equal to xs. You agree with me? And equal to what? Ea short circuit divided by Ia rated. So now, how can we get V phase OC divided by Ia short circuit? Okay. So based on this one, so we conclude that for open circuit, so V phase open circuit, okay, is equal to what? Ea rated. That's right. Okay. if we would like to calculate XS, we need to measure EA. How can we measure EA? How can we measure EA? How can we measure EA? We do what? We do open circuit test. Yes. We do open circuit test, you can get EA. And EA rate is open circuit. It's open circuit. Okay. And then we get IA short circuit. We get IA short circuit at that field the current from short circuit test. Okay. So for the specification, they will give you the relationship between IA short circuit and EA rated. Okay? Yeah. The company will do the test for us and they give us the curve. And then how many EA, how many IA, how many EA, how many EA. Okay? Yes. Of course, you know, we have the same 6 months. That means XS is constant. Find XS by applying the Hopf equations. Or here is EA, EA short circuit, and here is IA rated. The same, you know. Okay. What is this? I don't know. You know. Okay, 5 minutes. Try to understand this one. This is the first. Yeah. Now, try to understand. Pause. So look at these figures. We have how many curves? How many curves? 1, 2, 3. Okay. We have open circuit test curve. We have short circuit test curve. We have XS curve. Right? Yeah. So that means we have I choose open circuit test first. Okay. Yeah, we know the x-axis always IF. Always IF. Sometimes we use IF or little f. Okay. And this one is EA or V phase open circuit. You read with me? Yes. So we have the curve like this. I mean this one. OCC. Okay. For short circuit test, this one is what? This one is I. This is I. Right? I means armature current, and then we can get the curve like this short circuit test. This one also IF. We have the same reference system, you know. You know, we always choose the reference axis. Yes, of course, you know. Yes, of course. Normally, the reference axis is x-axis. And we have xs. xs. And look, xs, a positive ohm, ms volt. Yeah. So xs is SS is V phase open circuit divided by IA short circuit, or EA short circuit divided by IA rated. That means this value is divided by this value. Okay, here so this is linear, right? It's linear, this is linear. So we have the first zone here, zone 1. This is linear. This is linear, so xs is constant. Right? Right? Because if we increase a little bit II, that means we increase a little bit AI should interval is constant. The ratio is constant. Did you get me? That's right. We have XSE V phase short circuit divided by IA short circuit, you know. And this is linear, this is linear. So if we increase delta V phase, that means we increase delta IA, you know. Yeah. So this ratio is always constant. Right? The ratio is always constant. So XS is constant. Okay, now zone 2. Zone 2. Okay, for zone 2 here, for example here, this is what is it? This is like knee point. You know knee point? Yes, okay. So here we have zone 2. Zone 2. So for zone 2, this is non-linear. This is non-linear, more non-linear, you know. Because if this is slope, this is slope, this is slope, you know, more non-linear. This is linear, so you get XSE non-linear. Okay, but now for zone 3. For zone 3, this is XN, right? For zone 3, this is like linear. A little bit linear. This is linear also. So we get this one. Yes. So this is XS. Okay. So we have observation. Zone 1. You know, zone 1 is very good. Zone 1 is very good because we have XS is constant. You know, XS is constant. But for zone 2 and zone 3, to be careful, because XSE is variable, right? It's variable. And then if we operate the synchronous generator in zone 2 or zone 3, we get SF decrease. Right? SF decrease, that means short circuits increase. Right? AC constant. So if SS decrease, IA increase, and then the lifetime of synchronous generator is reduced very fast. Very fast. Okay? That's all. Any questions? Questions? Next. Oh my God, a lot of formulas. I don't like it. I think you need to understand this slide, okay, for yourself, because I am lazy to explain to you. You adjust to the thing, okay? Yes. So if someone can explain how can we guess this one, I give you 2% extra volt. 5 minutes. 5 minutes and then you get 2% extra volt. Come on. You can do any way to find the answers. Okay? And then you get 2% extra volt. Oh my God, very good. I hope so. Ở bên Đài Loan nó có một cái loại nhân tố rất là ngon. Như là về là thầy mua cho bà xã này 4-5 cái hộp luôn. Một cái loại bánh truyền thống của đó là bánh nhân cốm, pineapple cake, biết không? Pineapple nhân bên trong là nhân bằng cốm, dứa đó, ồ có ghiền lắm, thích lắm. Giờ đi của nhà vô thì ăn biết mấy hôm nay như mặt cái mẹ luôn, ngọt quá. Nó còn một cái loại bánh gọi là bánh muôn khác, bánh là cái bánh mochi, chai gì đó, mochi gì đó. Thầy là thầy nghiện Đài Loan, thầy sống ở đó 7 năm. Okay. Anyone can explain this slide? Maybe I will explain for you. No, now. This one is short circuit ratio. This short circuit ratio. Short circuit ratio is IF over IF, right? This is ampere. This is ampere. So that means we delete the unit. So we say per unit. Per unit. That means no unit. Because this is ampere, right? This is ampere over ampere. Skip. So they define the short circuit ratio. This is the IF when we do what? Open circuit test. Okay, we do. So when we do open circuit test, you can get rated voltage when we do open circuit test. And we know rated for open circuit test is what? E, A. Do you read with me? So we continue to increase IF. We increase IF and we observe open circuit curve. Okay. So if we get EA rated, stop. Okay. Yes. You know. So IF. So IF is high or small? Later on. Okay. So when we do IF here. Yeah. So we increase IF. And then we observe the IA, this is IA, right? So if we get IA rated for short circuit test, we stop. You can get short circuit ratio. Okay, so for example here, if this one is EA rated, you know, so this one is IFV rated open circuit test. This one. Do you agree with me? Yes. Yes. But I think this one is not rated, you know, maybe somewhere here. Okay, fine, leave it. So we need to consider here, you know, EA rated. Okay, yeah, so my leave it. Sorry. Okay, so here is yes. You know, yeah. And IA rated. IA rated is very small. IA rated is very small. You know. So here is IF IA rated. IA rated. Okay? Yeah. So this one very high. This one is very high. This one is small. So short circuit test ratio is very high. Right? Okay. Questions? Okay, so this is the definition of short circuit test. So when we get the short circuit test, we can calculate XS. Of course, XS is calculated by this ratio or this ratio, or we just take the inversion of short circuit test. Okay, this is per unit. You know, we take reciprocal of short circuit test, short circuit ratio, you can get XS. This is per unit. Okay, so if we apply this formula, you can get XS per unit. But when we apply this ratio, XSE, right? This is 1, this is M, this is O. This is per unit or no unit. This one is per unit. BU. How can we get this one? Look, this is my explanation. Okay, so first of all, we need to know XS per unit. XS per unit is XS actual value divided by XS base. XS over X base. You know, and XS here is what? XS here is equal to this ratio V5 open circuit divided by IA short circuit, right? Right? So we have XS is V5 short circuit over IA short circuit. Sorry, open circuit. Okay, this is base or rated. So that means, you know, XS is what? This one equal to V rated over I rated. Okay, so this is 1 over XS. Okay, so you make inversion of this one. So you get here is I rated over I or V5 rated. Okay. This one and this one equal. This one equal. Because for open circuit test, this one is equal. So we delete this one, you can get this one. You can get this one. We have IA rated. IA rated over IA short circuit. So IA rated, this is not equal, this is proportional. So IA rated is directly proportional to IF, I rated sub-circuit. Right? Here. It will have IA short circuit, IA rated. Okay, you can get IF rated. Okay. So for IA short circuit, okay, A directly proportional to IF, we rated open circuit. Open circuit. And look, here we get the IF, we rated over IF, I rated. So now this is reciprocal, right? So that means SSA is 1 over SCC. Okay, this is my explanation. Okay, so we take break 15 minutes.